Hello and welcome to the third week of the ordinary differential equations class. Here is the plan of today's lecture. Basically we are going to learn how to apply differential equations to model some real-life processes. In order to understand the lecture, you are going to use the knowledge from the first 2 weeks of the class. Basically these concepts are going to be very useful to understand the lecture. Let's make a few points. So recall that we are doing second order differential equations. We are doing the first order differential equations, and they are ordinary differential equations, meaning that the highest order of a derivative that you'll see here is 1. So we cannot have second order derivatives, and we cannot have partial derivatives. There are two large classes of first order differential equations that we know how to solve. So the first of them is separable. So in particular, here you see two examples of separable equations. So the first of them is clearly separable. So let me talk about the second one. So notice that you can rewrite the second equation as so first, if we move y to the left hand side, to the right hand side, then you will get minus t squared equals 1 plus y over 1 minus y minus y. And then times y prime. And then you can rewrite it as dy dt, which is y prime. And then if we divide everything by minus t squared, then we will get minus 1 over t squared times 1 plus y over 1 minus y minus y. And that's a separable equation because now the right hand side of our differential equation is written as a product of something that only depends on t and something that only depends on y. And here are two linear equations. So in particular, if we look at the first one, then here is the coefficient at y, and here is the free term in the right hand side. So the important part here is that there is nothing else. There is no y squared, there is no, cosine y, or so that there is just y prime, there is y with some coefficient that only depends on t, and there is the free term. Okay, so a few points is that the main idea to solve both classes of differential equations is kind of similar, and it involves integration. So that's why when you do integration, so remember that it always produces this plus constant, which means that the general solution of every differential equation, in the end, it contains a constant. Since it is a first order equation, we only have one constant. Doing this is different for two classes of differential equations that we have introduced. So there are other types of differential equations too, but we haven't learned them. And actually, probably most of first order differential equations cannot be solved explicitly. So it cannot be reduced to a simple integration. Recall that we also, in week 1, we introduced a few models. Free fall in air. Right, so here v is the speed of the object, and when it falls, then there is this part that is the gravitational acceleration, and this part represents air resistance. Right, so the faster it falls, the greater we have the air resistance, and which means that the object slows down. And here is Newton's law of cooling. Remember that Newton's law of cooling is when you have like a cup of hot coffee, and it is cooling down. So the A0 is the ambient temperature. So C is the temperature of the coffee. And then as time goes by, the rate of change is proportional to the difference of the temperature. A little problem for you is that now you can solve both of these equations in two ways, as separable or as linear, because these equations are at the same time separable and linear. And try both ways and report which one is easier.